Hello and welcome to another Clojure study group. My name is John Stevenson, and this week we're going to cover some more 4Clojure exercises. So 4Clojure is a website that has a bunch of challenges there which helps you understand the core functions that are within inside the main part of the Clojure language. And so doing these exercises helps you understand those functions and and helps you learn and hopefully remember what functions and what kind of things those functions do for you when you're trying to solve problems. And so this week we're doing 31 to 33, and they follow on from 30, which started looking at sequences in Clojure. And sequences is a nice kind of simple way to put an abstraction over data structures, so you can very simply treat especially lists and maps in the same way, just using standard functions, and it makes a very nice way to interact and manipulate data, which Clojure itself is really good at doing. So let's take a look at my desktop. I haven't moved to OBS yet, so we're still going to get the funky effects. Share that. Everybody, there we go, and here we go. So we've already covered 30 in a previous video, and so number 30 on 4Clojure was this how to compress a sequence. So essentially we've got this idea of a sequence. In this case, a sequence is, in this first example, it's a string. In this next example, it's a vector. And in this next test, it's we've got a number of vectors inside a vector. So it's a vector that contains several vectors, in this case 4 vectors. And so you can see in here, in the string, we've got multiple e's. In the list, we've got multiple integer values that are the same, and we want to remove those. And in the vector of vectors, we have 2 elements that are the same, and those elements are a vector of 1 and 2. And we've got a vector of 1 and 2 there. We do also have a vector of 1 and 2 here. So we can't just remove, strip out duplicates. We can only remove those that are consecutive. And so what we did was partitions by identity, and then we just grabbed the first value from those, and from each of those elements that we created. Let's have a look at that in the code. So this is the code for number 30. And again, I'm just rushing through this. Hopefully, if you want to go through some more detail, I did do that in the previous video. Let's look. So gone through here. We could have used a loop and sequence, but we've decided to partition because it's again, using partition is a nice abstraction over there. It does group all our values in a very nice way, and we can control how large of a partition we have. And oops. Where did that go? And then tried a few other experiments, but essentially, yeah. So partitioning by identity will just pick out. So it'll group 1 and 1 together, like we've done here. It'll group 2 by itself. It'll group 3 and 3 because they've got the same identity. And identity just means that if we do T on, oh, I'm not connected to my REPL. Oh, yeah. Oh, that's neglectful for me. Let's just start up the REPL. There we go. So if we do an identity of 5, then it should just return 5. So if the identity of 5 is 5, the identity of a string would be ring. what did I do? Oh, what am I doing? Oh. Oops. It has been a long week. There we go. Oops. So what basically it's just a way to return a particular value back. So it's really useful for working with partition. And then because partition returns this collection of lists, then we are just mapping over each one of those and just grabbing the first. So we return. We don't need both of them. We can just get the first one from 1, the first from 2, first from 3, and so on. And then we get our result there. And we can solve all our problems there. So we solve the problems. With a string, it's kind of separate that into characters. But because our look at our test, it's applying a string to that, so it actually fixes the fact that we're partitioning our string into characters. It's actually fixing that, so we can just return a string and it will match that. So that's kind of our first taste of sequences. So all these things are sequences. So basically any list or any vector can be treated as a sequence as well as a string as well. A string is just a sequence of characters. So let's have a look at some of the other challenges then. So let's look at 31. And there's an answer under there. I'll try not to show you that straight away. So we've got some more sequences here. And this time we're packing a sequence. So what's that say? So write a function which packs consecutive duplicates into sublists. So basically, we've kind of done this. Yes, I think kind of having 31 before 30 would have been a better idea in terms of going through these, but a lot of things are easier with hindsight. So let's see. Yes, we've got a sequence here that we want to pack into this shape. We've just got a vector of keywords that we want to put in there. So this looks, given what we've just done in 30, this looks fairly straightforward, I think. So it could just be, it could just be partitioning with identity again. So let's have a look at the code that I've created. So let's go back to my editor. Let's open the file, which I've already got, which is 31. So these will all be up on GitHub by the end, just after the end of the video broadcast. A bit bigger, there we go. So I've got the problem there. So yeah, we need to group the numbers so that they're consecutively the same number. So we're not just grouping, we can't just group all the ones together because they're not consecutive. So we've got a break here, we've got a 2 there, and then we've got ones again, and so on. So that wouldn't quite work. This one is pretty much just returning the same, but it's returning it as a sublist. So we are changing the structure. Yes, we're changing the structure of that because there's one more level of nesting, and the same for, and this one is just grouping the keywords. So hopefully it should be fairly straightforward. So we had a brief look at identity. So the docs say it's we can use identity to help group numbers together. Excellent. And it always returns the original value of the argument. So whatever argument you give to identity is going to return that value. I did look at group by as well. So group by is another way to sort of group values together in a collection. So we just give it a function to determine how we group by something and the collection itself that we want to group. And in this case, we're using identity to group by. And it's kind of giving some interesting results. So it is grouping by things. We're getting the right values. It's also showing like the value and the values that are in the collection. So you could actually almost, so this is returning as a map. So we could actually look up what values are inside a collection very easily by converting them into a map, and then you can just list all the keys that were there and see what values are in there, and also reference those values together as well, and even run count over the values to see how many there are of each one, or frequencies even. But it is not, with using group by, it's actually breaking things up into, yeah, it literally is just grouping things. It is specifically grouping numbers that are the same together. And so it's breaking this sequence that we had originally. So we've got 1, 1, 2, 1 here, and and below we've just got, whoops, it scrolls too much. Let's not use the mouse anymore. And so here, yeah, so here we've got a group of all the ones, and that's, we can't really use that because we need to have just the first 2 ones as a group. So we can go by partition. So there's partition. There's several partitions there. So there's partition, partition-by, and partition-all. There's also partitions, which will return all the intermediate steps as well. So there's quite a few interesting functions around partition, the partition family. So that's quite nice. So partition is quite useful for putting things into groups. And I've used partition-by because I found a limitation with partition. If there isn't, so if you want to partition something by, let's see. So if we're going to have, we create range of numbers from 0 to 9. Oops, 0 to 9. So I'll create 10 numbers from 0 to 9. But if we put that into our partition of 3, we've got 10 numbers, and 10 doesn't divide into 3, so we'll actually end up losing a number if we use partition. Partition, and we partition by 3, so we take each 3 values from there, and then we're just going to slurp in the range. And if we evaluate this, we'll get 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, 9's gone. So it drops off the 9, the last value, because it can't make a partition of 3 from that. And so I think I did look at this initially. I thought, oh, that's a bit of a problem. But then I looked at partition by and partition-all, and I think they do, certainly partition-all does get them all the values as well. So if let's just copy that. There we go. Partition-all. If we evaluate this one, then we get, oh, did that work? Oops. Interesting. I'm sure that gave you all of them. Maybe I'll come back to that in a moment. There is a way to get everything. Okay, sorry about that. I'll come back to that in a moment when I've figured out what I've done wrong. Okay, so for this one, so for back to the challenge, so we've got partition by identity here. So we're grouping up. So this is the data structure from the test that we were doing. So this is the first test where we actually got in the 4Clojure example, the 4Clojure challenge. And so it is kind of grouping things into the way we want it to do it. And partition by identity for the second test is also working okay. And it worked for the third one as well. So it's pretty straightforward. Once you understand, or once you've learned about partition and identity, then this is actually a fairly simple problem to solve. And yeah, so I just basically put in partition by identity to solve the challenge. And just to prove that it really does work, let's just run it, and it's all green. There we go. And I don't think there were any other solutions there that were, well, that's that one that's quite, somebody here has kind of basically manually done this. And yes, it obviously works, but it's quite a lot of work to do. Somebody's wrapped a partial around this one as well, which wasn't quite necessary. If you look at the here, so we're actually just putting the partition, because partition takes a function first as an argument, and then the second argument is a collection, then it actually fits in. We don't need to wrap partition partially. Yeah, it still works if you actually do that. So it's like writing partials, like writing an anonymous function in there. I think that's why they've done that. But yeah, that bit isn't actually needed. I think there's a few other manual ways of doing it, but yeah, pretty much people are partition by string. Interesting. Does that work? Obviously it does work. Yeah, so that I didn't find anything else that was particularly interesting there. There's some interesting answers like with loop and recur to explore. Again, loop and recur, you can always do pretty much whatever you want to do with loop and recur in Clojure. However, you do have to manage everything, and you are doing more iterative programming rather than like using functional abstractions. So it is more code, and therefore it's more code to manage and more code to read, and therefore more code for your poor little brain to try and understand what it all does. So using the abstractions it's much simpler to understand what that does, especially once you've got once you're comfortable with the idea of partitioning an identity. And even if you're not sure, you can actually just go in like I did before and try identity with some arguments and try partition-by with some arguments as well. And that helps you understand those problems pretty much. Any questions so far? No questions so far. Okay. Let's move on to 32. That's unsuspended. So I'll just jump in straight back into the editor for 32, I think. That's 32. Getting a sequence. So for this one, and we're still working with a sequence, this time we want to duplicate a whole sequence, but within inside the sequence itself. So we're duplicating the values inside the sequence by the looks of things. So we've got 1, 2, 3 inside a vector, and we want 1, 1, 2, 2, 3, 3 as the return result. And again, it doesn't matter that the return result is in the list. We don't have to actually convert it. And in fact, most of the functions we run on there will return a list as the containing data structure, because these are sequences in there as well. And it is really interesting to see, because when you're comparing vectors and lists, if their values are the same, it doesn't actually matter which they are, because you can both treat them as sequences. So so long as the values are equivalent or equal inside those collections, then the same thing in a list and a vector are going to be equal as well. So let's just show that actually. So if we want to compare vector of 1, 2, and 3 with a list, and because we're using a list, we'll need to quote it, because otherwise it'll try and call the first element of the list as a function, and we don't have a function called 1. So 1 is not a function. That would be very strange to have a function like that. But we've got the same values, but they're in different collections, but they're both sequences. So if we evaluate it, then they're both true. So they both equal each other. So we get a value, or a Boolean value of true. And so to deconstruct the problem, so what do we need to do? So we need to iterate over the collection and duplicate each value as we go along, and then put them all back into a same or same rough same shape of a collection. So we're not creating any sub lists or anything like that. We're just basically just adding an extra one after the one, an extra two after the two, and so on and so on. So for the 4Clojure ones, I go and it's an opportunity to go and see if there's actually a function that will just do this for you. Quite often there is, especially in the earlier numbered challenges, and you can go off and usually just do Clojure. If you type Clojure and then duplicate or Clojure partition, you would see if there's something there, and you can usually find something that's quite similar just by Googling for function names. And you can do that in, obviously, if you go to Clojure docs. So I usually, if I wanted to do, if I wanted to figure out if Clojure did something, do Google Clojure partition, and then if I click on that, it'll take me to Clojure docs. And if it wasn't quite the right function, there's lots of examples here that show me how it could be used, which is quite nice. But it also has some links into what other options, what other functions I could use. So cycle is quite an interesting one. And so obviously it's partition-all. Oh yeah. So yeah. So if I partition all, it returns a lazy sequence list like partition, but may include partitions with fewer items than n. Okay. We're on 4Clojure challenge 32. We want to duplicate a sequence. These are our tests. So it's pretty much just taking a value and just inserting a value after each value in the collection. So hopefully that's quite simple. So I did Google for a duplicate function, but couldn't find one for Clojure. I did find something called repeats. And so we could pass repeats. We could basically map repeat over the collection. In this case, I'm using an inline function. So I've written my own function here to take in a value from the collection. It will then repeat twice that value. And so we will get here, we'll get 1, 1, 2, 2, 3, 3. I think that would work for the, so that would work for the first example, kind of. It's giving us the right values, although if we look here, we've got a flat data structure here as a result. But when we do repeat, it's actually, because it's returning two values, this repeat function is going to return two values, so it has to return those two separate values as one answer, as one result. So it ends up putting those in a sequence itself. It's a list. So we end up having our overall result as being a list of lists, which isn't the structure we actually want, so it wouldn't be equal. But we have got the duplicated values, so we've made a little bit of progress, but we're not quite there. Simplify it so we don't have to use repeats. We could just have a function that takes a value and then just returns the value here. So here we're very explicit about what we're actually doing here. I'm using vectors here, but it doesn't actually make any difference in this regard. So we've still got a nested collection of the right values, but not in the right data structures. And let's see, yes. So we could use flatten, although flatten is a bit of a blunt tool. It's a bit of a like, let's just flatten everything, which sometimes you don't want to do. And it's usually kind of like the last resort. You've usually missed some kind of abstraction or some kind of approach if you have to resort to flatten. But it does work in the first instance. It does flatten our values there. And so for the first test, that would work okay. I think even for the second test, it works quite nicely as well. So yeah, I've just put this as an anonymous function here, so it would fit into 4Clojure. Okay. So I would put in this value in here. And that would be the 4Clojure answer. So that's just testing out with the particular value from the 4Clojure test. And so, yeah, those ones work. However, when we're trying to do it with, as you can see, the limitation of flatten here with the third test. So the third test has a vector of vectors as its data structure that we're going to duplicate. And it is producing the right numbers. So it is doing 1, 2, 1, 2, and then 3, 4, 3, 4, which we want. However, we've completely lost the vector of vectors, so we need to return that in the vector of vector shape. Back to the example, go back to the challenge. You see, we actually need to return, oops, that's showed you a secret there. So we need to return it back as 1, 2 as a vector, 1, 2, so we duplicate the whole vector, not just the numbers inside it. And then, okay, then we, okay. So again, it's an interesting way to show you that flatten is a very kind of blunt tool. It doesn't quite do what we need to do. And I tried a few things. I tried merging. That did give me kind of the right answer, but that also then did break the other tests because it didn't work. It wasn't flattening them there, and we didn't quite get the results we wanted there. I also tried reduce, but it wasn't really much better. We got first two worked okay, but we weren't reducing there as well. So, but it was a useful experiment to see what those did. So merging can be quite good to group things together. And then I looked at concatenate as well. Concatenate is quite nice. There's also, you can combine map with concatenate in the form of mapcat. That's also quite nice as well. So here we're duplicating the value just with a simple returning two of the same values, and then we're concatenating them together, which by itself doesn't do anything, but if we use apply, then we concatenate with that, and it reduces it down to the right function. So it's going to join all these sub sequences into just the one sequence like we've got here. And then we've got yes, we've applied concats to the test that has sort of a vector of vectors, and this actually does work. So that's looking very promising. We can apply concat to that, but it is kind of feeling quite heavy. It's quite a lot of work there that we're doing, and quite a lot of stuff to understand when all we really doing is just inserting an extra value. So I was starting to think whether there was a simpler way to do this as well, because we're mapping and then we're concatenating. So we're kind of doing a lot of work that's just there to kind of manage the shape of the results, which just feel a little bit unnecessary. And then we looked at mapcat. And so mapcat did simplify things quite nicely. So that does seem to be one way to do that. So mapcat is, as I said, is map and concat together. And so that is working for our simple values like 1, 2, 3, and also our nested data structure 1, 2, and 3, 4. So that gives us results. So that's quite nice. But we still need our own little inline function, our anonymous function here to to be able to do the duplication of that. So we're still using two functions, one which we've had to write ourselves. And even though it's a simple function, then still kind of wondered if there was something that I had missed. And so sometimes when finding functions is a matter of just being a bit of a thesaurus and saying, well, what's another word for duplicate, or understanding what are we actually doing. So we're trying to, so I realized we were trying to interleave values, and then that helped me lead onto interleaving with which is a function. So here I'm just calling the doc for the interleave function, and here it's just returning. So interleave just returns a lazy sequence of the first item of the collection, and then the second, and the third, and so on and so on. So if we just use it with one collection, it doesn't really do anything. But if we have multiple collections, then it will interleave those two collections. Let's put that on the top there. Oops. There we go. So if we just interleave vector 1, 2, 3, we just get a sequence of 1, 2, 3. But if we interleave two vectors of the same, we actually get the result that we're actually looking for. So we get 1, 1, 2, 2, 3, 3. So we actually duplicated the vector. Then we can then also kind of just interleave the results and interleave those two vectors. So I wrote a function which basically takes in a collection and then interleaves with both with that collection twice. So we give it interleave as collection, we give it the collection as argument 1 and argument 2, and then it'll interleave both. Then so we get the results. If I give that to 1, 2, 3, then we're getting our results of what we wanted. And then if we do that with the nested data structure, then we've got this collection coming in, and we've got duplication of all the sub collections in here, or the subsequences in here. Get the results. So we can use a function there as well, an interleave, or we can use mapcat, and mapcast, and there's a few examples here how to like do even terser if you're obsessing about your 4Clojure golf score, but you don't actually need to. I'd kind of be a bit wary about doing this because it does make it a little bit less readable. And you can also do repeat. So those are different kind of approaches. I think interleaving is a nice approach because it's a very specific. It's a specific function to do a specific task. And those are the ones that are nice and readable. And it also helps you kind of learn and remember interleaving as an option of a function you can use as well. What did I do? Let's go back to the browser. Did I change anything? Okay, right. So I did knock this down for a bit of a lower golf score. But essentially this is the same as this function. So we've defined a function here which takes the argument of collection and just returns that as well. And our golf score is just the our terse version of that is just interleave, and then these percents are the arguments. So that's the collection, and that's the same collection that we've passed in. So this is just the short form of writing that. And then so if we go in. And just to show it's not all magic and I haven't made it all up, let's run the tests. So we've got green, green, green. There we go. And again, I don't think there's any interesting solutions. So again, you can do this in loop recur if you wanted to. Mapcat, they've written their own duplication, and they've got a recursive function here because it's calling itself. So that's quite nice. Mapcat list. Yes, I've seen that one already. Oh, sort. Okay, into. Interesting. So that's basically So into is essentially map and conj, or reduce and conj. Sorry, yeah, reduce and conj, which we've got here actually. So these two are fairly similar, except that it's sorting the numbers just to make sure that they're the right way around. I guess that works because the numbers are always in order. So this is a bit of a cheeky hack, I think. Whereas interleave, as you can see, even in the short form, is still much more readable, I think. I don't think there's anything else there that's worth having a look at. No. Yeah. Okie dokie. All right. Any questions? No. I hope everybody's still with us. Okay. So we've got 20 minutes to look at the last one, and if we have any more time, we'll look at any more as well. So that's 30. So we looked at 30, 31, 32. Let's look at 33 now. And so we want to replicate a sequence. Let's go and look at that in my code. We've got quite a few tests here. Let's go and look at 33. It's a bit bigger. Okay, so we're going to replicate a sequence. We've got all our tests here. What are we doing? So we're taking a vector of 1, 2, 3, and we want to replicate it twice. And so we get that. So that's pretty much what we did in the last exercise. Now we're varying because we can't just use interleave, I don't think, unless interleave takes an option of how many things to interleave, which it may or may not do. This might not work then with interleave if we want to interleave 4 things. So we've got 4 A's and 4 B's. This is just interleaving once, so we actually just return it itself. If we have to do something manual, then maybe we can just do an if test to see if this value is 1, then just return the collection, and then we don't have to do any processing on it. And this is a nested data structure, and we want to do 2 of those. So again, that's kind of done something similar to that already. And this one is just, yeah. So it's only really the fact that we're doing 4 of these is tricky, may be tricky, and the fact that we're only doing 1 of those may be interesting as well. So let's have a look. I did solve this one, didn't I? Oh yes, I did. I wrote a function for this one. So we've already looked at repeat. So we're going to repeat that. We've looked at interleaving as well to get the result. And so if yeah, okay. So I was trying to. Oh, I see. Yes. So it's repeating the collection, and then using interleave on the results. So with repeat, we can repeat multiple times. So repeat. So if we want to repeat something 4 times, then we can do that as well. So let's just do that. 1, 2, 3. So here we can repeat 4 times. So we know we can repeat the argument that we get. So that allows us to tackle this test, to be able to repeat something 4 times, then interleave it. So we're not just doing a simple 2 arguments, or so we're not just returning 2 arguments. We're returning however many arguments how many subsequences of the arguments we've given, and so we can then interleave the results of repeats. I assume this is what we're doing here. So if we repeat twice, then we interleave. Let me just check. Oh, that's not. Did I get that wrong? Oh, right. Okay, right. So we have to. Oh, yeah. So we have to apply interleave over those 2 functions. Okay, yes. Oh, because yes. because interleave is getting this result. Evaluate that part. So if we just evaluate the repeat 2, then we're getting we're just getting a single collection, a single sequence. So we can't interleave the single sequence. We want to interleave the contents of that sequence, that content of that list. So therefore we need to use apply to do that. So we apply interleave. So it'll interleave with these 2 arguments instead of just one argument, which is the whole list. That's what we need to apply. Or we can then reduce works as well. I tend to think reduce kind of has more context for me, because I'm trying to reduce the numbers down into a simpler structure. And so make that into a 4Clojure answer. So the full version of that is just to define a function which takes a collection and the number of repetitions that we actually want, and then we apply interleave to the results of repeating by the number of repetitions the collection, and that gives us, if we put that in, if we call that function by putting it into a list and giving it an argument of the collection and 2, then we get our result. Fairly simple-ish function definition to do that. And I'm not sure if I came up with a simpler way to do that. So we're just trying to test that with other things. So here we are doing that with the 456, which is only repeating once, and that we get 456 from that as well. And so that seems to work for the first 2 tests. Although for some reason it's failing in the 3rd test that we did. So we go in and put this into the put this into here. Then it wasn't passing these, so I had to do it more. I've got that on there. So it passes the first 2, but it doesn't pass the 3rd one. And so we're not getting the right number of arguments. So we've got the problem here when we're just doing that. And so, because we're, because we're only getting a single, we're just getting a sequence. We're not getting a nested sequence. So we're unable to apply that correctly. I don't think if reduce fare any better, because there's a slight difference between, although apply and reduce look the same, there's a slight difference. Oh, we fell on that one. Okay, interesting. Cool. So we still need to kind of work through this a little bit more. Back to where we were. So we got to our function of applying there, and applying. So this worked for the tests. And I kind of, there's a bit of a difference, because I don't know if there's a difference in Clojure itself or not, but when I was doing this in the REPL, it was working okay, but actually putting it into 4Clojure, for some reason, it's not passing the tests. So we're actually getting the right answer here when we do 1, 2, 3, 4, but not that. So we had a condition. If we could add a condition to that. So if there's only 1 rep, if the amount of times we want to repeat something or duplicate something is only 1, then we may as well just return the collection without applying it. And then we can apply interleave to all the other conditions. So there's that one test where we just skip over processing the collection, and we just return the collection by itself. And then we can see what it's. That's what we would call. This is how we test it before we put into 4Clojure. And I thought, well, is there another way? Because this is tripping up then is there another way to actually get the right answer as well? And I realized I haven't really been using mapcat very much, so it's I thought about whether we could actually use that instead to do something. So instead of interpose, we can basically concatenate the values from something. So I guess interpose is a more specific version of that. It's basically putting values in there, but it's making sure that they're all the same. It's not changing the shape of things. And that's what concatenate we can do with concatenate as well. We can actually map over something which is going to expand the data structure a little bit, and then concatenate them. Use concatenation to pull those values back together. So we've used concat to with the same collection twice, and we'll get the right result. And then we can do the same thing. So instead of writing a function, we can just use partial here. So this is the same as it's actually the same. Oops, I mean to do that. Let's just copy that. So we could write our own function here if we wanted to. So we did function, and it takes an argument of call, and then we call repeats on that. That's not the right button. Slip that in, and then we put in call. We can pull in our collection and we just repeat it, and then we get the right answer. Obviously, because we're going to vary it, we can later on we can put in the value here, and then we would, instead of hard coding 2, we do rep. But this is giving us the right answer. So using mapcat is helping us work with that. So we're still repeating, but we're actually using mapcat. And if we just go, so we remove that for a second, and I can show you how we've gone from there to partial. So instead of doing this anonymous function, instead of this inline function, we can replace that by using partial. So partial will call repeat as a function with 2 arguments, but only 1 argument is there at the moment. So it's calling repeat with the number of repetitions. It doesn't have the collection yet. So when it's called with mapcat, then mapcat calls partial for the first time, but with the first argument. So it will return that. So it will pass the collection into this repeat. So it's essentially going to rewrite itself. So it'll do repeats. Repeat to, and then with the collection. So that's what will happen when mapcat first runs partial. It'll basically create itself into this function, which can now evaluate, because it's got repeats now got 2 arguments to work with. Actually, it's just a way to delay the execution of a function, only execute a function when it's got both of the arguments, and mapcat is giving it partial the second argument, which it then passes on to repeat. And we could just turn that into a 4Clojure answer by putting it into an anonymous function, and then we test it before we test it with one of the results there. And so this is the answer we've come up with, and we could again use the short form of this, which is hash for so this is the short form for a function definition, and we do mapcat, which is using partial. To call repeat n number of times. So n is the second argument we're going to get. So we can do %2 If I can find percent on my keyboard, there it is. We can do %2. So that's the second argument that we're getting. So this is the equivalent of this n and this n here. And then we can do, and then we want the collection, which is the first argument. So we can do %1. Or if you really were obsessive about your golf scores, you could just do %, because % by itself just means the first argument. So if we do this one, so that's failed. That one failed the unit tests, although it worked locally. Let's try this one. So we take the S for the sequence and N for the number of times we want to repeat, we want to replicate a particular sequence. If we run that, fingers crossed, it should go green, 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 green. Yay! There we go. And just to double check that I actually typed this in correctly, use the short form as well. Let's see. This should. So the previous version gave me a golf score of 33. This gives me, oh, what to do? Oh, that's interesting. Obviously didn't type it in correctly at all. Oopsie. What did I do wrong there? Oh dear, I don't know. Does it have to be? I don't think I tested this one. That would make any difference, to be honest. No. I'm going to have to look at that one. I've obviously done something strange in there. Anyway, but the other version does work. So that is, this one is working. This is the only challenge where I've had something that worked locally on the REPL, but didn't quite work in 4Clojure. I am assuming that there's a slight difference in the version that 4Clojure is using, but I would need to check that for definite. That's just an assumption. That works. Cool. And is there any other solutions out there? So doing con. So they've got a con to check whether it's empty. I don't know if that's really necessary, but I think that's quite good defensive programming. And they're using replicate as their own function. So they've got a recursive function to basically go through everything. Some of these may have been done before functions up there, but I'd be surprised. I think mapcat's been around for quite a while. Oh yeah, they've got the same, pretty much the same one as me. Okay. Oh, did I? Oh, I put it in the wrong place. Oh, there we go. I put the, yes. Oops. Yes. Oops. Yes, it's partial. So actually, yeah, so mapcats, this is the collection. This percent represents where the collection would go once mapcat is called. But actually, when you're calling this anonymous function, you're actually putting the argument is mapcat, the function it's using, and then the collection. So yes, so when 4Clojure was saying I had the wrong argument, then that was correct because I hadn't put it in the right place. Which is why it's actually sometimes better to do a more readable version of a function definition. I can just double check I got that right now. There we go. It's green, 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 green. Oh, there it is. It's working now. There we go. So it's very easy to do typo stuff there. And I think that's it. That's our time coming up. I apologize for the break we had in the middle due to a power supply. Let's see if I can find out what's going on in my area. But again, thank you very much for joining me. If you have any other ideas about what you would like to see in these study groups, please let me know, and we will do my best to try and do that. I'll try my best to have a less messier hair as well. It's been a very busy week. But again, thanks very much for joining, and hopefully see you on another video. Thank you very much. Bye.